Most DAX functions are useful. Some are powerful. But calculate? Calculate is the engine that makes DAX a true analytical language. If you understand this function, you stop writing formulas and start controlling data logic. The basic syntax of the calculate function is as follows. Calculate, open parenthesis, expression, comma, filter 1, comma, filter 2, and so on, then close parenthesis. Calculate is one of the most powerful functions in DAX because it evaluates an expression under specific conditions. The first argument, called the expression, is the calculation you want to perform. This is usually a measure such as total sales, total profit, or average revenue. The remaining arguments are filters. Filters modify the context in which the expression is evaluated. They tell DAX to recalculate the result using only data that meets certain conditions. Let's start with a simple measure. Total sales equals sum of sales amount. This measure calculates total sales across all available data with no filters applied. Now, suppose you want to calculate sales only for the year 2025. To do that, create a new measure called Sales 2025. Use the calculate function and place the sum of sales amount as the expression. Then add a filter condition specifying that the sales year must equal 2025. What happens here is important. Calculate modifies the filter context. Instead of summing all sales, it restricts the calculation to only rows where the year equals 2025. The result is a dynamic measure that always returns sales for that specific year, regardless of what other filters exist in the report. This is the key concept behind calculate. It is not just compute values. It controls the context in which calculations are performed. Understanding this behavior is essential for building advanced Power BI measures. Calculate can override filters, add filters, remove filters, modify relationships, perform time intelligence logic, and enable conditional calculations. Here is a common business request. Management asks for total company revenue that remains constant, even when report users apply slicers or filters. Normally, when a slicer is used, Power BI filters the data and recalculates totals based only on the selected values. But in this case, management wants a number that always shows the full company revenue, regardless of any selections. To solve this, create a measure called total revenue all. Use the calculate function and set the expression to sum of sales amount. Then add the all function as a filter modifier and reference the sales table. The all function removes any filters applied to that table. This forces the calculation to ignore slicers, filters, or visual selections. As a result, the measure always returns the true total revenue for the entire dataset. This type of measure is commonly used in dashboards to display baseline metrics, company totals, or benchmark values that should never change with user interaction. The key insight is this. Calculate controls filter context and all removes filters. When used together, they allow you to override report selections and return global values. Here is another common business question. Management wants to know the total revenue generated by gold customers only. In a typical report, revenue might include all customers. But in this case, the calculation must be restricted to a specific customer segment. To solve this, create a measure called gold revenue. Use the calculate function and set the expression to sum of sales amount. Then add a filter condition specifying that the customer loyalty status must equal gold. This filter tells DAX to evaluate the calculation only for rows where the customer belongs to the gold segment. Calculate modifies the filter context so that even if other customers exist in the dataset, they are excluded from this result. The measure now returns revenue generated exclusively by gold customers. This type of calculation is widely used in business reporting to analyze performance by customer tier, membership level, region, or product category. The key takeaway is this. Whenever a business question includes the phrase only for, it usually means you need calculate with a filter condition. Here is a common executive reporting question. Management wants to see each region's revenue as a percentage of the company's total revenue. A standard revenue measure will show sales for each region, but it will not automatically compare those numbers to the overall company total. To solve this, create a measure called revenue percent of total. Use the divide function to safely perform division. Set the numerator as the sum of sales amount. This represents revenue for the current region. For the denominator, calculate total company revenue. Use calculate with the sum of sales amount again, but this time apply remove filters to the region field from a store table. Remove filters removes the regional filter context. This forces the denominator to always return the full company revenue, regardless of which region is being evaluated. The result is a percentage showing how much each region contributes to total revenue. When placed in a table or chart grouped by region, each row will display that region's share of company performance. This type of measure is widely used in executive dashboards, performance scorecards, and market share analysis. The key insight is this. The numerator respects filters. The denominator ignores them. That contrast is what allows you to calculate contribution percentages correctly. Here is an advanced business scenario. Management wants to calculate revenue based on delivery date instead of order date. In the data model, there are two relationships between the sales table and the date table. The active relationship connects order date key to the date table. The inactive relationship connects the delivery date key to the date table. By default, Power BI always uses the active relationship when performing calculations. So if you create a standard revenue measure, it will automatically calculate results based on order date, not delivery date. But in this case, the business specifically wants revenue analyzed by delivery date. To achieve this, create a measure called revenue by delivery date. Use the calculate function and set the expression to sum of sales amount. Then use the use relationship function to activate the relationship between delivery date key and the date table. Use relationship temporarily activates the specified relationship for that calculation only. It does not change the data model permanently. It simply tells DAX which relationship to use while evaluating that measure. As a result, the calculation now returns revenue grouped according to delivery dates instead of order dates. This technique is extremely useful when a table contains multiple date columns, such as order date, ship date, invoice date, or payment date, and analysts need different time-based perspectives. The key concept is this. Calculate changes filter context. Use relationship changes which relationship drives that context. Together, they allow precise control over how data is evaluated in a model. Imagine you're a data analyst presenting a revenue report to company executives. They're happy seeing current revenue, but they want deeper insight. They ask, can we compare this period's revenue to the same period last year? So you need a calculation that automatically shifts the selected dates back exactly 1 year. Here's the DAX measure that solves it. Revenue last year equals calculate sum of sales amount. Same period last year using the date column. Let's break it down. First, sum of sales amount calculates revenue in the current filter context. Second, calculate changes that filter context before running the calculation. Third, some period last year replaces the selected dates with the exact same range 1 year earlier. And just like that, your report now shows year-over-year comparison automatically. Executives can instantly see trends, growth, or decline without manual calculations. Time intelligence in DAX works by modifying filter context. Once you understand that, you can master any time-based comparison. You're reviewing a company revenue dashboard with management. At first glance, revenue looks strong. But then the finance director asks a sharper question. How much of this revenue actually comes from profitable products? Because here's the reality. Not all sales are good sales. Some products sell well, but cost more to produce than they earn. So total revenue alone doesn't tell the full story. You need revenue filtered to only profitable transactions. In this business, profit is defined as revenue minus cost times quantity. So for each sales row, you must check whether sales amount is greater than cost multiplied by quantity. That means this calculation cannot rely on a simple filter. It needs a row-by-row logical test. Here's the DAX measure that solves it. Profitable revenue equals calculate sum of sales amount. Filter sales table where sales amount is greater than related product cost multiplied by quantity. Let's unpack what's happening. First, filter scans each row of the sales table. Second, related pulls the matching product cost from the products table. Third, the logical condition keeps only rows where the sale is actually profitable. Finally, calculate sums revenue only from those filtered rows. So instead of total revenue, you now see revenue that truly contributes to profit. Why this matters for business? Management can now identify products generating real value, products that sell but lose money, opportunities to adjust pricing or cost structure. When business logic depends on row-level conditions, combine filter with calculate and related. That's how you turn raw sales data into decision-ready insight.